So this session we have sanitation designs, and we've seen a number of very good presentations so far, and we've been really sort of almost taken to task in some way. We've heard from Oxfam that 40% of latrines are not being used. There's a huge disparity there between female usage and male usage, which came out of the lighting presentation that Brian gave from WEDC as well. And some very interesting presentations on fecal sludge management. Now we have two presentations. Sorry?
And we're supposed to be sitting up there.
So we've got Murry, Burt from UNHCR, who's going to give the first presentation. And that's on UNHCR's Global Waste to Value portfolio. So handing over to you, Murry.
Okay, can you hear me through this? Yep. Thanks, Tim, for the introduction. What I'm going to do today is just take you through a bit of a tour of what UNHCR is doing in terms of waste to value sanitation interventions. Just to start off, to highlight the point that in many situations now, particularly with refugees, but also protracted conflict situations, we're working in much longer time frames and looking at protracted situations. And the average lifespan of a refugee operation now is extending over 20 years. So we're looking at much longer horizons. So the focus very much is on how can we develop long-term access to wash services and adopting more cost-efficient solutions. And this is where the concept of waste to value comes in. So when we talk about waste to value, we're talking about taking products from the waste stream, and particularly looking at human waste stream, but also UNHCR considers domestic waste streams and turning them into value-added products. And there's four categories there you can see on the screen that are commonly seen as value-added products. So biogas for cooking or lighting, briquettes, carbonized briquettes, which are used for cooking like coal, production of electricity, and production of fertilizer. When we talk about waste to value solutions, one of the problems is if you focus particularly on the human waste stream, that the calorific value, the energy value in human waste is actually quite low. And it's never going to be able to be this perpetual motion machine where you take the waste and it provides all the energy. And it's normally 20% or often a lot less than 20% of the fuel needs can be generated at a household level. And so you often need to introduce other waste streams in from agricultural waste and other types of waste to make it viable. And there's some numbers there, and you can look at these in more detail on our website or on the presentation. So just to overview what UNHCR has been doing with its partners, and I'll highlight work that we've done a lot with Oxfam, Sanovation, and some other partners throughout this presentation. We've been looking at biogas, and this has been a journey that we've been moving on since around 2013, and you can see there on the charts. We've also been looking at the solid waste briquettes, urine diversion dry toilets, and this is probably the longest intervention we've focused on. And then in a range of countries you can see on the screen there. I just want to highlight today one publication that we've just launched. It's in fact I've been informed only uploaded to our website today. There's the web address, and it's a piece of work really driven by Oxfam over that time period on urine diversion dry toilets and capturing what we consider to be best practice learning around UDDT, particularly in refugee situations. And it's had a focus on work in Ethiopia, in Dolowedo, and also Gambella is the final area. So quickly to summarize what we've got to is we've learned a lot about urine diversion dry toilets and the pros and cons, what works well, how to introduce them, the soft side as well as the hard technology side. And you can see on the screen there just some key points about The cost savings around UDDT is generated because of the infrequent emptying, and I've got another chart at the end looking at the cost difference between a pit latrine, which needs to be replaced every 2 or so years, whereas a UDDT you can take the waste out and the structure remains. It does have the possibility to be used as fertilizer, but so far we haven't successfully used that in practice due to social implications and logistical constraints. And we've also included some work with CDC looking at the pathogen die-off rate, and there is some more work to do in this, particularly around ascaris and helminths, which seem to be not dying out as quickly as we thought that they would, and that was actually presented at a previous EEHF. The user perceptions around UDDT in this context, surprisingly, have been very positive. And so from the user interface side, it's had a good acceptance. And I think this is also captured in the standard operating procedures, is around the importance of the soft side of introducing a new technology and working well with the community. And Oxfam has really done a great job at that. And then we've looked at the possibilities of the waste product reuse for composting. The fact that if you're handling waste, there's a need for a multi-barrier approach to safety and lack of recontamination. And then the fact that at this stage we can't guarantee that it's pathogen-free waste, and so there's been a recommendation to use on non-food crops at this stage. Moving on to the Briquettes, we've worked with Sanovation, which is a social enterprise company, and this project has been focused on Kakuma in Kenya. And you can see there on the screen the process that they go through: a customer-oriented waste collection, waste treatment and transformation into the briquettes, and then an affordable fuel. And so cost savings come in because you can sell the fuel, and also you can charge people for the service if you provide a service. Just taking you through the technology. It's a container-based toilet system, so basically a bucket latrine where the bucket is filled and then exchanged, the full one for a clean one, by the collection service. And we've been running this project since 2014 and beginning a scaling up process now as the technology in terms of the collection treatment process has been proven, but we're needing to look more now at the business model side and the financial viability. Just stepping you through the process through some pictures here, you can see the toilet at the household level. There you've got the collection system. There's a picture of the waste processing plant, and this has evolved, and the technology they're using is much more advanced. And then the final product, the carbonized cooking briquettes. One interesting thing to highlight is that the volume of human waste is very small. It's less than 20%, and the volume of what they're using is carbon dust is much higher, around 80 or 85%. So it brings to light this fact that you need to have multiple waste streams to make this viable. You can see here some numbers around the number of households that so far have been using this system, volume of waste collected, and the sort of number of briquettes that can be produced from that waste. This one is a similar project where the numbers have come out of Ethiopia, and you can see the 900 kgs of solid waste. It reduces a lot once you dry it and carbonize it, and it is really only supplying for 3 households, in this case in Ethiopia. So it can't be viewed as a solution to your cooking fuel problems, but it's a way to reduce the cost of sanitation by being able to get some value added out of the waste product and sell that onto the local market. I've already highlighted that alternative feedstocks are required. In Kakuma they used carbon dust, and in Ethiopia they've been looking at agricultural waste products, so grass, maize cobs, bamboo, and mirror waste that can be introduced into the briquette making process. Another third technology that we've looked at is biogas. We've got some examples here from Bangladesh. This is actually pre the current emergency, where we had 2 relatively stable refugee camps and not actually high numbers of refugees. But within those, we found that given the density of the population, that biogas was actually a viable solution. And in many refugee contexts, it's not, because we actually asked for more space for the refugees and to create livelihoods opportunities. But in the context of Bangladesh, it is a very dense environment. So we installed 53 bioreactors, and it was attached to 915 toilets. So it's a relative scale there. And then at the other end of the waste stream, there's 53 communal kitchens with cooking gas provided. And there's been a process of a rotation of use of the kitchens and sharing the gas. And once again, it's not at all solving all the cooking needs of the camp, but it's supplementing other fuel sources. And many people within these camps are using LPG gas cookers, and so this is a type of cooking environment that biogas is well accepted into. In Ethiopia, we've also experimented with above-ground biogas digesters and transportable gas impermeable bags, so you can actually move the gas around. And this hasn't been as successful as the Bangladesh model. I think that there's some elements of it which are interesting, that you can transport the gas, and so it can be produced in one production plant in large scale, and then transported to where people use it. But so far within Ethiopia, that hasn't been highly successful, but it's an interesting approach, and I think that we may try it some other places. As I said earlier, we've done some financial analysis around these technologies, and we're normally comparing them with a basic pit latrine and seeing where we get a payback period, thinking of a longer life cycle of these protracted refugee situations. So for UDDT, you can see the numbers here. After around 5 years, we're starting to say that we've got a cheaper sanitation solution than if we had just continued with basic pit latrines. With the Sanovation carbon briquette model, at this stage, it's a much longer payback period, and this is to do with the investments that we've put into the processing technologies. Biogas actually has had the payback over the shortest period, and I think this is to do with a comparison with LPG gas, which is much more expensive than the methane gas produced through the biogas plants. But interesting to see these cost comparisons. And the other thing that we've looked at very much is in difficult sites, and often these are what we get for refugee operations, with rocky ground conditions, high groundwater table, and congested sites like we've got in Bangladesh, then these are the places where basic pit latrine won't work. And so we need to come up with more robust solutions and above ground options. And that's where particularly UDDT becomes interesting, and this containerized collection system that Sanovation provides, which could also be quite useful in urban contexts. And I know that there's other operators like Sanergy who are using the same type of technology in urban slum environments in some cities around Africa. Looking to the future, we're on a journey. We've got some good funding partners, and Gates Foundation, I have to recognize, has been a good funding partner to develop some of these technologies and look at ways to reduce the costs of providing sanitation services and refugee operations, is continuing to partner with us. And so some of these technologies will take forward, others we think that we've reached some level of conclusion. And so particularly the UDDT, I think we've reached a level now where we can say we have some robust operating procedures. Those are now published on our website, and feel free to use them. We may need to tweak the technology, adjust some things, but I think we've come to a place where we have a good workable model looking at both the soft side and the hard technology. So we'll be looking to scale that up across our programs. With biogas, there's still a lot more work to do. I'm not convinced that biogas is the silver bullet, and it has an appropriate place in some situations, but not definitely everywhere. So we'll be looking at where we can scale this and replicate it. In terms of new developments, we're looking at, particularly for like the carbonized briquettes, looking at mapping different types of feedstocks we could bring in, and even looking at where we could integrate domestic waste streams, so solid waste coming out of refugee operations, to look at how we can turn that into potential cooking fuels. So there's a lot more work to do with operational research and scaling, and particularly I said around the business model side of what Sanovation is doing, and how that can apply in refugee context. And this relates a lot to what UNHCR calls the comprehensive refugee response model, where we're looking to have refugees more integrated into national systems with the right to work and then the right to pay for services. And so that's where the Sanovation model becomes quite attractive. And in a similar way, integrating with private sector and what's their place for providing sanitation services within refugee camps. The work we've done with Sanovation is the first time we've worked with a social enterprise to provide sanitation services. And that's come with its own set of problems of how does UNHCR and a UN agency work with private sector. So we're working through those processes too. So that's all I have for you today.